Hello there. So in this video, we're going to talk about malware analysis. We're going to see how a security researcher approaches an incident of a malware attack at a company or organization and how they try to dissect the file and collect information about the malware and investigate what it does or what it has already done in the past and what data has been compromised and all that stuff. So if you're someone who is interested to learn how malware can be analyzed, then this video is just for you because we are also going to take a malware sample and analyze it. Now, obviously, this is going to be a very beginner level approach. It's going to give you a basic idea about how malware analysis works and different tools you can make use of. So make sure you watch this video until the end. So in this video, we're going to use a Linux toolkit called REMnux, which is basically a Linux distro that contains all the necessary tools that are required to perform malware analysis. So you can go ahead and install REMnux on your computer or install it in VirtualBox. But what's better is if you can install it and run it as a Docker container. Now, by doing so, you're making sure that REMnux is completely isolated from your computer. And even though when you're performing malware analysis, and if you happen to accidentally execute the malware file, and you do not intend to do so, it's not going to do much of the damage because it's just a Docker container. You can just destroy it and spawn up a new container without any damage. So in this video, what I'm going to do is I'm going to make use of Kasm Workspaces, which is a Docker container streaming platform. And by making use of Kasm, I will be able to run REMnux right from my web browser. I can basically just spawn up a Docker container of REMnux from Kasm and stream it directly from my web browser. So let's get started. The first step is to install Kasm Workspaces. If you're a regular viewer of my channel, you already know how to do so because I've already made a couple of videos on Kasm. So you can install Kasm on your own local Linux machine, but what I prefer to do is I prefer to install it on a virtual computer that is hosted somewhere on the cloud. And by doing so, I'm making sure that none of the Docker containers that I run are running on my computer. They're running somewhere on a virtual computer. So anyways, I have created an AWS EC2 instance to install my Kasm. It has 2 virtual CPUs, 4 gigs of memory, and 55 GB of SSD storage, which are the minimum requirements to install Kasm. So let me go ahead and quickly log into my EC2 instance from my SSH client. All right, there you go. So now let's go ahead and install Kasm. I'll leave a link to this official Kasm installation guide. You can refer to it and you can install it. I'm not going to show you step by step how to install it because I've already done that in my previous videos. So I am just going to copy all these commands and execute on my SSH session. And this is going to install Kasm. It's going to take around 10 to 15 minutes to install it. Oh, and meanwhile, if you're wondering whether Kasm is free to use or not, let me tell you, the community version of Kasm is available for absolutely free of cost. It has all the basic features that are required to do your thing with Docker images. But if you want the professional and the enterprise version, which gives additional features like custom branding, session casting, etc., you can subscribe to them as well. And for me, the people at Kasm were generous enough to give me an enterprise key for Kasm Workspaces, so I can even set up my custom branding, which we're going to do in a bit. All right, so once the installation is done, it gives you some credentials like this, which are required to log in into your Kasm dashboard. So I would just copy all of this and paste it up in a text editor so that I can access them later. Go to https:// followed by my public IPv4 address. Click on advanced, click on proceed, and there you go. There is my Kasm Workspaces login page. So I'm going to quickly copy my username and my password that is randomly generated and log into my Kasm Workspaces, and there you go. That is how the dashboard looks like. So one advantage of having an enterprise license to Kasm Workspaces is that I get to customize my Kasm dashboard with my own custom branding. So let me go ahead and quickly show you how to do that. I'm going to go to branding here, click on add config, and I can just give my branding details here. So I'm just going to brand it as TechRaj, the host name, techraj156.com, and I can give it a favicon logo URL. So I've uploaded my icon to ImageBB, so I'm just going to copy the URL here and paste it in the favicon logo URL. And for the header logo URL, I'll be making use of this image. Copy the link here, paste it. I also get to choose the launcher background URL, for which I've chosen this image. Paste it here. I'm also okay to choose a HTML title. I'll just give it as TechRaj, logo caption. I'll just give my website URL there. Login logo URL. I'll be making use of the same. Click on submit. And there you go. The branding config is now successfully created. All right. Would you look at that? This is my logo and here is my caption. So now coming back to Workspaces, here you can see all the pre-built images that Kasm comes with. You can also see REMnux here. And it is grayed out, which means it's disabled. So we have to go ahead and enable it first before we can use it. So go back to admin again, and then click on Workspaces. And in this list, go ahead and search for REMnux. There you go. There it is. You can just click on edit here and then just select enabled here and click on submit. So this is going to enable the image. So if you come back to Workspaces, you can see REMnux is now available, but you can also see this exclamation icon here that says that this image is still not downloaded. So give it some time, like around 5 to 7 minutes, so that the REMnux image can be pulled from Docker Hub and it can be set up on Kasm. So I'll just pause the video here and come back once REMnux is ready to go. So once REMnux is ready, you can see it is now available. I can just click on it and open a new session in new tab. Click on launch session, and that's going to open up REMnux in a new tab. I am now able to use REMnux Linux distribution in a browser. Just like that. So I can do all of the malware analysis stuff right from my browser like this. And if you want to upload a file from your local computer to your REMnux session, you can just click on this arrow icon here and click on upload file. Click here, and this is going to open up a file dialog box like this, and you can select the file or folder that you want to upload into your REMnux session. Once you are done using REMnux, you can go ahead and delete your session so that it will completely erase everything. Your container, your Docker container of REMnux is going to be completely destroyed. So before moving on to actually performing malware analysis on a malware sample, let me show you one really cool feature of the enterprise version of Kasm Workspaces. There is something known as session casting, using which you can share the session of your Kasm Docker apps to anyone. Let me show you how to do that. So if I go to admin here and click on casting, I can go ahead and click on add config and let me create a casting configuration here. For example, I want to share my REMnux image with people so that people can spawn up a new container session of REMnux and use it from their browser. So I'll name this as REMnux, and the URL key I'll also set up as REMnux. Under workspace, I'll search for REMnux, and then there are different options that you can configure. For example, you can allow anonymous usage, and then if you want to stay safe from bots or web crawlers, you can even enable reCAPTCHA by Google. But for now, I'm just not going to use reCAPTCHA at all. And anonymous user group, I'm going to select all users because I want my REMnux session to be available to all the users. You can also limit the total sessions. For example, I'll set this as 15 so that once 15 sessions are created, users will not be able to create any more sessions. Similarly, I can even limit the request per IP address. There are even more options that I can configure. And finally, I can also set an expiration time for my session. Finally, click on submit, and that's going to create the casting config. So if I just copy this casting URL, open up a new window, and if I paste it here, you can see it is loading up the REMnux session. It's creating a container of the REMnux image, and now I am able to, access my REMnux session from my browser. So I can share this URL with, people that I want to share my session with, and they will be able to use REMnux as well from their browser. So now let's go ahead and actually perform malware analysis on a sample that I got. So there are two types of malware analysis. The first one is called static analysis, and the second one is called dynamic analysis. Static analysis is where you try to dissect the malware file without actually executing it on your lab setup. But when it comes to dynamic analysis, you actually execute the malware file on your lab machine and you monitor its behavior to understand what it is doing. So in this video, we are going to do static analysis, which means we are not going to run the malware file on our computer or on our REMnux. But what we are going to do instead is we are going to dissect our malware file and understand what it does when it is executed on a victim's computer. So over here, I have a file named training sample, which is the malware sample that we are trying to analyze. So first of all, what I'll do is I'll try to find out what kind of a file it is. And we can simply do that by using the file command. So I'll just say file followed by the name of the file, which is training sample. And it says here that it is an ELF 64-bit LSB shared object for x86-64 architecture. So when you see ELF, it's nothing but a binary file that can run on Linux. So this sample is created to be executed or to be run on a Linux machine, but not on a Windows machine. In order to know more about this file, you can use a tool known as Detect It Easy, short for DIE. So if I just open DIE, I'll just type DIE and hit enter, and that's going to open up Detect It Easy. So I'll choose my file here, which is training sample. And it shows you all the different kinds of information about the file. It shows you the entry point of the file, the base address, and most importantly, if you see here, it shows you the operating system on which it was compiled, the compiler that is used, and the version of the compiler, the language in which it is written, C and C++. So this information is very useful when you're trying to understand the source of the malware, which is in which language it is written, which compiler is used, which version of the compiler is used, etc., etc. And also when it comes to malware analysis, the malware sample that you are trying to analyze might have already been analyzed by someone else, by some other security researcher across the world. So in order to check if your malware has already been identified as malware and if there are any reports already written for it, you can first try to find out the hash of your malware sample file, and then you can search this hash on services like VirusTotal, or simply just perform a Google search to see if you can find any information about the sample file that you're dealing with. So in this case, I'll make use of MD5 sum. So I'll type in MD5 sum followed by my training sample, and this is going to give me the MD5 hash of the file. So if I just copy this, if I go to my web browser, I will go to VirusTotal and I'll try to search with my MD5 hash here, and let's see if it comes up with anything. So you can see it says that no security vendors and no sandboxes flagged this file as malicious. And this is because the training sample, the file that we are using right now, is not an actual malware. It is only written just as a training exercise. So it's not actual malware, but if you perform the search with the hash of a real malware that has already been detected as malware by security vendors and antivirus softwares, VirusTotal is going to right away tell you which security vendors and which antiviruses detected that particular file as malicious. Since we're dealing with an ELF binary here, we can make use of a tool known as REMnux to read the different properties of this ELF file. For example, if I want to display all these symbols in the ELF file, I can use the -s flag. So let's actually go ahead and do that. I'll say read ELF -s followed by my file, which is training sample. And look at that. It displays all the symbols from this ELF binary file. So what these symbols enable you is that they help you uncover the name of the functions and the name of the global variables that are used in the source code of the file that we are analyzing. In this case, this training sample file. So you can see there are two symbol tables. The first one is called .dynsim. And the second one is called .symtab. So .dynsim contains the symbols that are dynamically linked. In other words, these function names are not actually part of the actual source code of the malware, but they are linked from external libraries which already exist on the operating system. In most cases, the dynamic symbols are not much used to us because these are all generic functions and generic global variables that exist in common external libraries, but they can help you to figure out what functions this particular malware is using from the external libraries. So let's move on to the second symbol table, which is .symtab. You can see the type of the symbols. We are looking for the type called func, which stands for function. So over here, you can look at the name of the actual functions that are used in the source code of this malware sample. So these are the name of the functions. So by looking at the names, you can intuitively figure out what that function does. For example, look at this function name here. It says ping_google_DNS. So just by looking at the function name, we can expect that this function has something to do with pinging Google in order to check if the target or the victim is able to connect or access the internet, something like that. And similarly, you can also look at the object symbol type, and usually these object symbols are nothing but the name of the global variables that are used in the source code. For example, look at this entry over here, which is the object symbol type, and the name of that is sum_string. So we now know that there exists a global variable in the source code with the name sum_string. So once again, the name of these variables can also tell you or hint you what data or what kind of data is being stored in that particular variable, which comes really handy in understanding what the malware's behavior is. The third type of symbol is file. You can see here. So what this file tells you is the name of the actual source code file that is compiled. In this case, you can see that the name of the source code file is training_sample.c, and then there's another file known as crtstuff.c. Now, the name of the actual source code files can also reveal a lot about the malware. Usually, when you have the binary, the final compiled binary of a malware, the name is not going to be suspicious because malwares are disguised as some other software. But if you get a chance to look at the name of the source code of the malware, it can also tell you a lot about the nature of that source code. For example, if I were to write a keylogger in C programming language, I would save my source code as keylogger.c, and then I will make use of the GCC compiler to compile it into a binary, and I will rename that binary, disguising as something else. For example, I will rename it as free internet download manager or something like that, so that people do not get suspicious. But the name of my actual source code is still keylogger.c. And in this way, if someone is able to read the actual name of my source code, they will be able to figure out that it's not a free download manager. Instead, it is just a keylogger. Similarly, let's go ahead and look at all the program headers and sections of this ELF file. So I'll say read ELF-L to list out all the program headers and the corresponding sections, followed by the name of the file, training sample. And let's see what it gives us. So you can see there are 9 program headers in this ELF file. What we're interested in is this load program header, because this is where the actual executable code is loaded into the memory. You can see there are 2 program headers that are named as load. If you look at the first program header, you can see it has read and execute permissions, but the second load function has read and write permissions. So when you see read and execute, that is when you know this is the actual code that is going to be executed when you run that malware. On the other hand, when you see a read and write permission, this is the segment or the program header where your file's global variable data and your dynamic linking information is stored. And below that, you can also see the section to segment mapping. A segment is nothing but the program header. So just a quick observation, you can see the text section is actually mapped to the first load program header, which contains the actual executable code. So whenever you see a section named .txt or .text, that is when you know that this section actually contains the executable code that gets executed when you run that particular file. And that is why it is also mapped to the first load program header with the read and execute permissions. Anyway, the reason why we are looking at the program headers and the corresponding sections is because sometimes malwares can be packed. A packer is a software that is used to compress a file, and this can be used for malicious reasons as well. You see, when you pack a file, you're basically obfuscating that particular file, which means when someone is trying to analyze your file, they do not get to see the actual source code that you wrote. Instead, it's going to be all gibberish. The way a packer works is that it can either encrypt or compress the actual malicious file in order to make it look like something else, so that whenever an antivirus software sees this particular malware file, it will not be able to detect it as malicious immediately because it doesn't look like a malicious file. So when you execute a malicious file that is packed, what happens is that the packer actually unpacks the malicious file, loads it into the memory, and then executes it. So in case of malwares that are packed, it is very hard to do static analysis. So let's actually go ahead and look at an example here. So I have another file here that is named as training sample static packed. So as the name suggests, it's a packed malware file. So if I run file on it, file training sample static packed, oops, let me try that again. You can see it also comes up as an ELF binary file. So if I go ahead and use read ELF now and read the program headers and the corresponding sections on this file, let's see what it tells us. So you can see there are only 3 program headers. There are only 2 load headers and 1 GNU stack header, and there are completely no other sections available. When you see that an ELF file only has load program headers and a GNU stack header like this, that is when you know that the file you're dealing with is packed. So if I go ahead and pass this to detect it easy, let's see what detect it easy tells us. So you can see it is showing us that it is packed using a packer known as UPX, which is a very popular open source packer, which is widely used by malware developers. When you see that a file is packed using an open source packer, you can try to Google and see if you can somehow unpack the file because it's open source. So in this case, since it's using the UPX packer, we can go ahead and easily unpack it. So let me go ahead and show you how to do that. So I'll type in UPX space -d followed by the packed file, and it says unpacked one file. So now if I say read ELF-L training sample static packed, you can see now there are 6 program headers, which means our file is no longer packed. Just to confirm that, we will also try to use die here. So let me open up die and let me pass this packer unpacked file. And there you go. It no longer says that the file is packed. It shows you the compiler, the version of it, and the language it is written in. So another important tool that comes really handy when performing static analysis is something known as strings. So if I just type in strings followed by my training sample file and hit enter, it displays all the ASCII readable texts that are embedded in our target file, in our malware sample. In this case, you can see there are a lot of ASCII readable strings and it is displayed every single one of it. Now in this list of strings, you can find a lot of information stuff. For example, you can find the string named as Google DNS ping, which we have seen earlier in the symbol. It's nothing but the name of the function in the source code of that file. And we can also find something that looks like a base64 encoded string. So a lot of times when you're analyzing a malware sample, you will find base64 encoded strings like this. And the reason is because malware developers try to obfuscate their code. They want to make sure that when you look at their code, you will not be able to instantly understand what their code is doing. And that's why they tend to encode different things inside their code. And here it looks like they have encoded some information as base64. So let me copy this base64 encoded string and let me try to decode it with base64 utility. So I'll type in echo followed by the string, and then I will pipe it out to base64 and I will decode it with the -d tag. So let's see what it says. So the decoded string goes like this: wget followed by http some non-existing cnc.com/malware.app. So it looks like our malware sample is trying to make a request to this particular URL using wget. In this case, this URL obviously doesn't exist because, as I said, it's not a real malware. It's just created for training purposes. But when it comes to real malware, you can uncover a lot of interesting things, a lot of interesting strings by making use of the strings command, and you can essentially even find out what the malware is trying to do by looking at the ASCII readable text. And another interesting thing is that you can even try to do a string reuse test to see if the same kind of strings are used in any other malware. So there are a lot of services that offers this string reuse search. One of the services that I use is called Integer. So you can go to analyze.integer.com and you can do a string reuse search. So I'll paste my string here, click on search. And in this case, it says string not found because once again, it's not real malware. But when you're performing your analysis on a real malware, you can make use of services like this to see if the similar kinds of strings are used in some other malwares that are already detected by antivirus softwares. Since we were also talking about packed malware earlier, let's see what happens when you try to run strings on a packed malware file. So over here, I have a malware sample that is packed. So let me try to run strings here on that. And let's see what it gives us. So you can see it has a bunch of gibberish. This is because the packer compresses or encrypts the actual source code of the malware, and that is why you can see a bunch of gibberish here. But you can also see some useful text that says this file is packed with the UPX executable packer. So that tells us this particular file is actually packed with a packer named UPX, and that's one way of finding out which packer is used to pack a particular malware file. But everything else is just gibberish. It just makes no sense because this is not from the actual source code of the malware. All right, so the final tool that I would like to show you is known as Ghidra. So you can go to applications, go to development, and you will find a file named as Ghidra. Ghidra is a very popular tool when it comes to malware analysis. It is developed by none other than NSA. It can be used to decompile a binary file and read its source code, and also to debug it while performing dynamic analysis. So first of all, I'll go ahead and create a new project here, and then I'll go ahead and import my file, training sample. And once it is done importing the file, it shows you the summary of the file, like the compiler ID, the architecture, minimum address, maximum address, MD5 hash, SHA-256 hash, etc, etc. And now you can just go ahead and double click on the imported file, and this is going to decompile the file and open up a code browser that looks like this. So you can go ahead and click on yes to analyze the file. Click on analyze again. So on the left side, you can see an entry that says function. So you can just double click on it, and you will find all the different functions that exist in this particular binary file. So we will look for an entry function or a main function because that is where the execution of the program starts. So there you go, there is a main function here. If I just double click on it, on the right hand side, you can see the actual decompiled version of that function. You can actually read this code. It's written in C language. So you can see the functionality of the code. It's first trying to install wget using apt get install wget, and then it is doing something like this. Now you might remember this string from earlier. This is the base64 string that we have decoded earlier, and we know what it is. It's nothing but a wget command. It's trying to make a request to some particular URL using wget, and that is also why it's installing wget before trying to use it. So obviously there is nothing malicious in this code here because it is not malicious, as I said. But let's actually try to open up an actual malicious file, an actual malware using Ghidra, and let's see what we can find. Over here, I have a sample of a very popular ransomware known as WannaCry. You can see it is a PE32 executable, which means it is built for Microsoft Windows. So let's actually go ahead and try to open this up in Ghidra, and let's see what Ghidra gives up. I'll double click on it in order to open it up in the code browser. On the left side, you can see the symbol tree. I'll go to functions, and then there is a function that says entry, which is the entry point for this program. So I'll double click on it, and you can see the decompiled version of this function. So all this code is actually a boilerplate code that is generated for every Windows PE32 executable. What we are interested in is the final function call here. So if I double click on it, I'll be taken to that particular function, and check this out. You can find a URL like this, and if you are aware about the story of how WannaCry came to an end, then you probably already know what this URL is. Well, let me give you a spoiler. This is actually the kill switch for WannaCry, and let's actually try to figure out how it works. It's using the Internet Open A function. And you can learn more about the function on the Microsoft documentation. It says here that it initializes an application's use of the wininet function. The wininet library gives you the ability to communicate in a network. So basically to access the internet. So it's opening up that handle, and then it's making use of the Internet Open URL A function. You can refer to the documentation of Microsoft here. It says that it opens a resource specified by a complete FTP or HTTP URL, passing in the uvar1, which is the handle that it opened previously, and then it's passing the ustack_64, which is nothing but this particular URL. And then here comes the interesting part. It checks if the request to that particular URL fails or not. If the value is 0, it means that the request has failed. So then what it does is it closes the open handles and calls another function. But if the request doesn't fail, if the request is successful to that particular URL, it's just going to close the handles and then return, which is going to just quit the program. So now it makes sense how this is a kill switch, right? Because what it's basically doing is it's checking if the request to this particular URL succeeds or not. If it succeeds, it's just going to kill the program and not continue with actually encrypting the files. So that'll be it for this video. I hope you learned something new. If you did like this video, please do not forget to leave a thumbs up below and also leave a comment in the comment section. If you're not yet a subscriber, please do hit that subscribe button and also turn on the bell icon to receive instant updates from my channel. I'll see you in the next video. Until then, cheers.